Problem 1. A researcher wants to find a regression model. Y hat is A plus Bx for predicting weight. Weight is Y from height. Height is A of women swimmers. She collects data on weight Y and height X of 5 swimmers and in 5 pairs of data. 3 computer outputs are given below. Choose the correct output to answer the following questions. Output A, the key points are N is 5 correct. Here Y, false. There must be X. Output A2, N is 5. And X, height is X, correct. C, output A3, dependent variable weight, correct. Height X, correct. Height X, yeah, correct. And 4, false. So this is false. So from 3, we choose this. Problem 1. If a swimmer's height is 63 inches, what would you estimate her weight to be? X is 63. Estimate height, weight Y hat. So Y hat is A plus BX. X is 63. B is 5.5. A is negative 240.5. So now you can compute and put the answer here. 106 pounds. The next question. Perform a test to determine whether there is a significant linear relationship between weight and height in the population. Y hat is alpha plus beta X in the population. If beta is 0, then the equation does not show any relationship between X and Y. If beta is not 0, if X changes, beta X will change, therefore Y hat will change. We will see the relationship between X and Y. Therefore HO, beta is not 0, beta is 0, HO. There's statistic, T statistic, where here, T statistic 5.9655. So if you cut 3 decimals, 5.966. That's statistic. What is p-value? What is p-value? P-value is mentioned always near the statistic, this one. This is two-tailed p-value always given. So your test is also two-tailed. Beta is 0 or not 0 is two-tailed. Therefore, you just copy directly the p-value from the table. Now, recall that if p-value is more than alpha, alpha is here 0.05, p-value is 0.0094, some more. If p-value is more than alpha, reject HO. Note this rule. After that, write formally. The decision must be about HO. Rejected. Rejected means false. Therefore, HA is true. H is true. HO is false. H is true. Therefore, beta is not 0. Therefore, if X changes, Y will change. Y X and Y have Y are in a linear relationship. HA is true. Problem 2. The chief of police of a city is considering increasing the number of police in an effort to reduce So the meaning is, in his idea, if the number of police increases, crime will decrease. This type of relationship is called inverse relationship. And in this sentence, it is described number of police as X and number of crimes as Y, but confirmed later also. Before making a final decision, he surveys other cities of similar size to determine the relationship between number of police and the number of crimes reported. The researcher wants to find the regression of the number of crimes. So in this sentence, in this phrase, crime is Y on X number of police. Now correct. Two common outputs are given below. Choose the correct output to answer the following question. So number of observations, H, here H, here H same, and dependent variable number of crimes, dependent variable Y is number of crimes, and here number of police H, that is all consistent. In output 2, and here number of crimes, here must be X, but this is Y, so this is false. This is the correct one, the answer. So regression equation, you can write standard error estimate ST. Where is SE? SE is square root of MSE. This is SE, okay. 3.378, yeah. And SP, what is SP? SP is here. Number of police X, yeah, B is negative 0.95963. This is P. SP is here, standard error, SP. So you get this. Interpret the coefficient of determination. You write about R square in percentage form. R square is here 0.7646. Therefore, percentage is 76.46%. 76.46% of the variation in Y number of crimes is explained by the regression model or explained by the number of police X, like this. And you get all answer. And 5. Negative linear relationship. That is, in the equation for the population, y hat is alpha plus beta X, and beta will be negative. Yeah. This is the meaning. Yeah, if beta is negative, then if X increases, Y will decrease. If the number of police increases, the number of crimes will decrease. So this is less than if HA always. So HO is not less than. HO not less than. Yeah? Not less than. You write formally, not less than means greater than or equal to. And you know where to find the statistic, the value, yeah, how to write the conclusion from p-value. Problem 3. An industrial psychologist would like to develop a model to predict Y. Therefore, the number of typing errors is Y based upon X. So X is the amount of alcoholic consumption, measurement ounce, ratio level, number of typing errors, counting, ratio level, based on a random sample of 8 typists, and if 8, 3 common outputs are given below. Choose the correct output to answer the following questions. A1, here n is 6, false, this one false. A2, n is 8, correct. How about this? Number of errors, this is Y, this is false. There must be X here, but in this output, this is Y, so not this one, only A3, And if A correct, here alcoholic consumption is correct. No? So about A3 you have to use, and now you know how to do this and perform it. Positive in a relationship, beta is positive, yeah. So HA, therefore HO, beta is not positive. Formally, beta is less than or equal to 0. The statistic is here, T statistic 3.99, and P value is here 0.007, very small alpha, yeah, with the HO and so on.